So this is a very typical left ventricular hypertrophy, and most important thing is whether there is LA dilatation or not. That can be made out through this aortic root diameter and this LA diameter. If both are same, then there is no LA dilatation. But if this is more and this is less, then obviously LA is dilated. So you have to put your cursor, your probe in such a way that you can see the LA in a better way. LA and aortic root. Yeah, you had put, now it's coming, and maybe at some point we can freeze it and see. So yeah, you see, diastole, look at the aortic root, look at this. Now let's see the systole. Systole also, if you see, this is still more. Although we are supposed to see in systole only, in this. We put the remote cursor and then we see it, but it's not required. Here we are just eyeballing, we are not measuring anything. This is more. Now, so we now already know that she has got HFpEF, heart failure with preserved ejection fraction. She may not be having any symptoms. Meeku emana ayasam unda? Naduste? So leading question telling us that she has got HFpEF. Now, the most important thing here, this eyeballing, how much is it moving? So you put your thing there and let us see. Focus on this mitral annulus. You have to bring it well. The aorta should be visible, like this. Here the aorta is not. First you get that picture. Good. Now see, once you get it, now this is the place. So the mitral annulus has to move and come back, and it should not move anteriorly. It is going anteriorly. This itself is showing that there is a diastolic dysfunction. This is a very typical. This mitral annulus moves anteriorly like this. This is very typical of diastolic dysfunction, which is again because of the left ventricular hypertrophy, which has caused this increased left ventricular diastolic pressure and caused the LA dilatation. So this is all coming from eyeballing. We have to, I didn't do the review from that transcript of that echo YouTube video as to whether somebody has published this or not. This feature showing that is diastolic dysfunction. Yeah, I'll need to clarify that. But it's a very good video which is showing that. So would you like to also show the patient without the face? Okay, right. Ventricular hypertrophy is quite characteristic here, but you have to get the aorta. And you can see this movement, this one. So when it contracts and there's a systole, this is supposed to go there but not supposed to go anteriorly. And then it's supposed to come back quickly. So that quickly coming back is not happening and it's going a bit anteriorly. That is what we are imagining or seeing or whatever. Okay, we'll have to work on this further, this thing. That will be part of your thesis, where you look into how this can be a good tool. First thing we will have to do is review the literature around this as to mitral annular anterior displacement as a marker for left ventricular diastolic dysfunction. There are many markers of diastolic dysfunction, none of them have been proven to be good enough, and whether just a quick eyeballing of this can give us a good idea is what you'll have to see. So you keep on doing it for every patient, you'll be able to become adept, and more practically you can pick it up very quickly. Okay, so we'll stop it here. We'll collect this for your archive. Now you can turn it to the 90 degree and see the short axis and look at the left ventricular hypertrophy here as well. So again you have to do a little bit so that it comes well. You can see the right ventricle here, there is the left ventricle. Now you can take it to the apex and you can see the left ventricular hypertrophy. You can see the mitral valve here, right ventricle and right atrium. Okay. And you can put some color to see if there is any mitral regurgitation, aorta, any tricuspid regurgitation. And then finally you can see this is another marker for diastolic dysfunction, where you see the E and A wave by putting this here, and you can bring down this baseline through what? Which one to bring this down? Angle correct. This baseline. Okay. Right. So you see, this is another marker for diastolic dysfunction. If you have the E wave which is very high and the A wave is proportionally not that high, that's another very important marker. And then of course you have to see the deceleration time and all that. So this is again a very important pointer towards diastolic dysfunction. So two things are correlating. That mitral and annulus, and this one. Both are correlating. So good. I think we will keep it at here. So heart failure with preserved ejection fraction, symptomatic, and of course she has had stroke as well, and 5 years back, and she's got diabetes and hypertension. So all these problems are compounding, and one day she'll come to you with systolic heart failure also. But she's already in the throes of heart failure. Okay.